Hi, everyone. I'm the program manager on the Microsoft Identity platform. And today I'll talk a little bit very briefly about an overview of what the platform offers, and then move into some details on the MSAL Java side and what we have been working on recently. So the Microsoft Identity platform is built using industry standard protocols such as OAuth and OpenID Connect for offering authentication and authorization services. It enables application developers to sign in users with Microsoft identities like work or school accounts on Azure AD, personal MSA accounts, or even customer and partner accounts with their own identities. These capabilities are surfaced through certified OpenID Connect endpoints, and application developers can integrate with the platform using these endpoints. But to get quickly started, developers can get started on the Microsoft Identity platform by registering their applications and then using the Microsoft Authentication Libraries we provide to sign in users and access various protected APIs secured by the platform, such as Microsoft Graph. So we offer a bunch of different Microsoft authentication libraries in a variety of languages. For example, JavaScript, .NET, Android, iOS, Python, Java, Angular, and more recently, we built the Microsoft Identity Web Library for .NET Core. Today, we will be talking mostly about Microsoft Authentication Library for Java and some work we've been doing to improve the developer experience. So what is the Microsoft Authentication Library? As I mentioned, Microsoft Authentication Library is an SDK that interacts with the endpoints on the Microsoft Identity platform and takes care of a lot of the authentication flows and handles a lot of the auth logic for you. So MSAL Java enables applications to sign in users with Microsoft identities and get tokens for authorized access to APIs which are secured by the platform. So like I mentioned, the MSAL Java gets tokens. It's primarily a token acquisition library, and it provides authentication and authorization flows to get tokens in multiple application scenarios. For example, in web apps, in desktop apps, in daemon services, in command line apps, as well as web APIs. We are doing ongoing efforts and innovating continuously in MSAL and adding more and more features to improve resiliency and security of the library. Recently, we released a bunch of different samples for web applications using MSAL Java. So some of the scenarios we covered in this sample, which is laid out in a tutorial fashion and with multiple chapters that you can pick and choose. Each chapter is its own independent code sample that you can download and run. But every subsequent chapter allows you to build over the previous chapter and gives you that continuity of the scenario. So the different scenarios we have covered today, the sign-in scenario, signing in from a web application using Azure AD or Azure AD B2C, acquiring access tokens to get authorized access to call the Microsoft Graph API, then signing in users and restricting their access to specific roles or group claims which come in the token. And finally, we also show you how to deploy your app to Azure App Service once you've built it. We will go into more details about a sample, and Sam, who's my colleague, will be walking you through a demo and some code snippets. So I'll hand it off to Sam at this point.
So if you're wondering how to add authorization and authentication to your servlet web app using the samples that were just shown you in the chapter-wise tutorial in the previous slide, it's just in 3 easy steps. Just we open the configuration file, we populate these 3 settings that you see in step 1 here. In step 2, we just call the sign-in method in auth helper. That's going to utilize the Microsoft Authentication Library for Java to complete the auth code flow. It's going to redirect the user to Azure AD's login endpoint, and the user will enter their details. Then their browser will be redirected to the redirect endpoint on your servlet web app with an authentication code. If everything checks out there, the auth code will be exchanged for an ID token and an access token. Step 3, you get to use the ID token to extract its claims. What's the user's name? What are some roles they belong to? And also use the access token to access upstream resources. Okay, so I've cloned the repository in question here that you saw in the previous slide, and I've navigated to chapter 2 and I've navigated to a sample called call graph within chapter 2. So this chapter is about signing in a user and obtaining an access token for graph. Then I've gone into the source/main/resources folder, and there's a properties file over here. And all I'm going to do over here is I'm going to add the details of my application that I've registered on the Azure portal. Next, I'm going to run the app. I've already packaged the app and I've deployed it to Tomcat, so I will just open it up over here. Normally, you'd have to package it at this point after changing those details. Let's sign in. Okay, great, we're signed in. So allow me to show you what happened right there. So when we clicked sign in, this servlet, the sign-in servlet, was activated, and we used the sign-in method in this auth helper. Auth helper is just a class with some static methods in it that help us utilize and surface some of MSAL, Microsoft Authentication Library for Java's features. And this particular method triggers the auth code sign-in flow. All it needs to take in is a context adapter so that it can technically be used in a non-servlet application as well. But we've given it a servlet context adapter with a request and a response so that it can read and write information from the session. So what it does is call this method here. It will either authorize, it will either get a token silently or interactively. Silently if there's already a valid token in the cache, it will use that instead of asking the user to log in again. Otherwise, it will redirect the user to the authorization endpoint. It'll set up some of the parameters that are required to do this. So it's going to create a random state, random nonce, save them, and pass these along with the request to login.microsoftonline.com. At this point, as you saw, I clicked on an already signed in account there, and Azure AD redirected the browser. When that happens, we've set it up so that it redirects to the application, which in this case it's localhost :8080/MSAL4J servlet graph /auth/redirect. Over here, yeah, we just use auth helper to process the Azure AD callback, again with a servlet adapter in there. There's an interface there called identity context adapter in the helpers, along with auth helper here. You can implement that for your specific needs if you're not using a servlet. Here we just validate to make sure that the response we're receiving is correct. And then if everything checks out, the state matches, there's no errors, we will take the auth code that we received and send that to the token endpoint of Azure AD and exchange that for our ID token and access token, and then validate those. If those are all valid, we save these to the session, so that in the next request that the user makes, we can fully take advantage of the ID token or the access token, or both. So in this token details servlet, we've created a context adapter, and then we've gotten the context data from it. And then here we just filter out some of the claims in there to display to the user. For example, let's take a look at the ID token details. A subset of the claims in the ID token are displayed here. Another thing we can do with this, with the data we've obtained from the token endpoint, is one of the other pieces that we've obtained was the access token. Now that we can use that to access upstream resources. In this case, we take that access token and we give it to the graph client that Vincent will demonstrate soon. And that allows us to call graph. That's basically the gist of how one would do authentication and authorization in a servlet web app.
So I just wanted to mention that thanks, Sam, for that overview. What we have next is a bunch of samples we are building for Spring Boot apps. And we will soon be having more samples for the Java developers. But if you would like to see something more in the Java SDKs or samples, please go ahead and fill out the short poll that we have in this deck. I'll share out the link even in the chat. But yeah, please feel free to check out the poll and take a few minutes to provide your feedback. With that, I think we can hand it off to the Graph team to go into the Graph SDK.
Thank you, Navya. Hi, everyone. I'm Maisa, and I'm going to talk about Microsoft Graph Java SDK, and Vincent is going to be doing a demo for us. Now, we can't talk about the Java SDK for Microsoft Graph without first speaking about the Microsoft Graph itself. But what is Microsoft Graph? There are many things that build the applications and services that makes the Microsoft 365 ecosystem. In the past, each of these teams exposed their own API. Well, you can imagine how difficult it was to handle with all of them at the same time to build an application, right? So the Microsoft Graph is the gateway to data and intelligence in Microsoft 365, giving developers a unified programmability model to take advantage of the tremendous amount of data in Office 365, enterprise mobility and security, and also Windows 10, under a single consistent API, which directs the calls to the right source. That way, developers don't need to know where exactly the data lives. And now you may ask, okay, but what is the benefit of knowing where the data lives? Well, it's quite simple to answer that. You don't need multiple tokens to access multiple APIs, for example. To make this more concrete, let's give you some examples. Here are some of the entities available in Microsoft Graph. Developers can build an app that, based on a security alert in a tenant, can traverse the graph to see which users might be affected, making it easy to connect data from across many services to solve a real business scenario. Devs can also build apps with richer content accessing deep insights generated from user patterns, such as trending documents, best team meetings times, or people typically work with. Some of the common scenarios are find the OneDrive files that a user edited in Word last week, or schedule time for a meeting with a group on their Outlook calendar, update a planner task for a user based on their group membership, start a new conversation thread for a group in Microsoft Teams. It is also possible to cover scenarios with real-time updates of the data, like reschedule a meeting based on a response or notify others when a file is modified. Best thing to get started is to head over to aka.ms/ga to try the API with the Graph Explorer. For those who are not familiar with Graph Explorer, it is a customized developer tool that allows you to try Microsoft Graph and offers a great advantage since it handles authentication process for you, letting you choose on sign in to your own tenant or use the default sample tenant. And in addition, this tool includes helpful features such as code snippets for each REST API query you select on the left sidebar. You can see the code under Code Snippets tab as it's showing in the print screen. You can use Graph Explorer as a prototyping tool to fulfill your app scenarios. Okay, now you know the Microsoft Graph and Graph Explorer. This brings us to the next question: how to integrate with Microsoft Graph? Is it difficult to do that? And the best part comes. Well, we have all these SDKs for you to easily integrate and use Microsoft Graph. But what does the SDK have to make this integration simpler? Let me show you. They are designed to simplify building high quality, efficient, and resilient applications that access Microsoft Graph to make you more productive. First of all, the SDKs are available to be included in your project via GitHub and popular platform package managers such as Maven and Gradle. So the library contains models and requests builders that are generated from Microsoft Graph metadata to handle the boilerplate logic for sending and receiving requests, so you can work directly with the responses instead of writing HTTP connection logic yourself. It is also commonly necessary to handle with query results. For performance reasons, collections of entities are often split into pages, and each page is returned with a URL to the next page. The SDK provides a class to simplify consumption of paged collections. For batch requests, there are a set of classes to simplify how to create batch payloads and parse batch responses. There are many extensibility points with the SDK that make it easier to perform tasks. Graph SDKs embedded support for effective handling of failed requests and redirects, large file uploads through a fluent and easy mechanism for the consumer to control, monitor, and cancel the handling of large uploads. And the authentication providers that implement the code required to acquire and use the token. And now talking more specifically about the new version, we select a few new features and improvements to highlight in this call. We will soon share the link to the blog post that contains all the information about V3. This new version of the SDK now takes advantage of Azure Identity to improve the authentication experience, providing support for device code flow, which Vincent is going to show in the demo in a few moments, and client certification credentials grant flow, which were not previously supported. We all know it's important to have the possibility to call the Microsoft Graph in the background, to not block the main thread in your application. Taking this into consideration, the custom interface to asynchronous request has been removed, and the API now returns completable filter to deliver a standard, modern, and fluent user experience without compromising on the code maintainability. Talking about fluent experience, the batch support has been improved to provide a cleaner API surface to SDK users. The SDK now also produces methods to include the count of items in collections. This change allows you to write more specific requests, reducing the permission required for your application. That is no longer necessary to use query option or custom requests to get the number of records. Now, when we talk about providing modern, more reliable, and faster date and time API, calendar has been replaced by offset date time, covering a broader set of scenarios and providing more consistent APIs. And then, to align with the SDK design specifications, we removed unnecessary interfaces to avoid confusion and duplication, refactored package names and classes names to clarify the intent of them, and moved all code from the service library to the core library, since the service library was designed to contain code generated automatically from the API metadata. So that gives you a kind of overview of what is the Microsoft Graph, the benefits of using a SDK, and also some of the new features in Java SDK v3 version. So enough slides. Let's get straight over to a demo. Now I'll hand to Vincent, and he's going to show you how to use the library in an interactive way.
Thank you, Mesa. So here I have Visual Studio Code open to a sample application, and I'm going to show you the new features from the Java SDK v3 in action. The first part we can see here. So first, I'm in a console application. That's a very simple kind of application based built on with Java, and it has limited UI capabilities. So the first thing I'm doing here, because again, Microsoft Graph is always secured and behind of authentication, as Sam and Navya told us right before. I'm actually setting up the authentication context. In this case, I'm using the new device code credentials support that we added with the v3 of the SDK from the Azure identity that also uses MSAL behind the scenes to authenticate. So the first thing I'm doing here is creating the device code credential, passing it my client ID, my tenant ID, and it will print a message telling me to authenticate in a few seconds. Once I have this object, I just put it into the authentication provider, and I can pass all of that to my Graph client builder to get to Graph client. So before we go further, I'll start debugging. And you can see that the first thing that's going to happen after my application is built and started is that I will get a message here telling me, hey, you need to authenticate. And because, again, we're using device code flow, which is very well suited for IoT applications or applications living on devices that have limited user input capabilities, it's telling me, hey, go to microsoft.com/device login, enter that code, and then I'll be able to resume what I'm doing. So this is what I'm going to do. I'm going to go to microsoft.com/device login, enter the code, select my account, and that's it. My application is ready to run and to call Microsoft Graph. So the first thing we can see here is the usage of a new asynchronous API. So we still have the Fluent API we had before, where we take the client and we have a bunch of resources that are available under it for all the different things that are on Microsoft Graph and that are available on Microsoft Graph. And then after we do that, we can do /me to get the current user, build the request, and we can do get async. So that will effectively execute an HTTP GET request, but it would do so asynchronously. And then I can leverage the APIs provided by completable features that are standard way of managing asynchronous work and kind of a work that has to be done on a separate thread in Java to handle the response, handle any exception, and so on and so forth. This is really important if you're building any kind of UI-based application, either for Java or for Android, or if you are building a server-side kind of application, a web server that's calling a graph behind the scenes, or if you have a high volume of calls that you're making to Microsoft Graph. Why? Because if you're blocking on the main thread, the UI might freeze, the web server won't be able to accept new calls or not as many new calls that it could accept otherwise, and so on and so forth. By doing that asynchronously, you're freeing the main thread to do other things, like handling new requests or handling updates for the UI. And then some background thread will actually go and do the work to call Microsoft Graph, get the response back, deserialize the response, and so on and so forth. Of course, you still have the synchronous blocking API as well. So that's the exact same call, but using the synchronous API that's available in the SDK as well. So you can see that it's very similar. You could still use graph client.me.build request, but in that case, instead of doing .get async, you do .get and you'll get the response right away. But again, that will block the main thread. Also, so if I go to the next breakpoint, you'll see that the SDK still has object and models for the different entities that live in Microsoft Graph, things like users, messages, security policies, anything that lives in Microsoft Graph, we have it in the SDK. So that gives you auto-completion, compile time validation. Also, the documentation is provided there. If I go, for example, do that, you'll see that not only I have the property here, but I also have the documentation coming from the documentation. All of that has been improved with v3. Now we have, for example, nullable and non-nullable annotations all throughout the SDK to tell you whether something might be null or not, and whether you need to handle that possibility or not in your code to make your application more resilient. And all the documentation annotations also have been added to the SDK to make it so you can use the SDK and discover the graph and what's available without having to navigate back and forth between your IDE and the documentation pages on your browser. Now, the next thing I want to show are actually two things here. First are the Fluent API support for OData query string parameters. So you might know that Microsoft Graph supports OData query string parameters to select some fields, to order things, to count things, to limit the numbers of results you want to get, and so on and so forth. That allows you to tweak very specifically the request you're sending to Microsoft Graph. So it sends you back a very specific response, and you optimize by reducing the numbers of back and forth calls you're making, by reducing the payload you're getting back. So all of that will participate to make your application faster and provide a better user experience. Previously, we did not have OData query string parameter support in the Fluent API. This is something we've added recently. And now, instead of having to build that manually in the URL or add manually all the options, well, you can just use the Fluent API like I've done here to say, all right, I want for the messages for the current users, I only want 2 messages, not more than that. I want to order them by the most recently received. I want only to select the subject and the receive date time, and I want the global count of all the messages in the inbox. So all of that is supported supported for us. So if I go to the next breakpoint, you will see that here I do have, in effect, 2 messages that came back with the different properties, like the subject, the ID, and the what else did I select? The receive date time. And you can see also that the SDK support, and it already supported the ability to iterate over pages. So again, because I only selected 2 messages, but there are many more messages in the inbox, I have this ability to keep querying Graph and tell Graph, hey, give me the next results, give me the next results, give me the next results, and the SDK will do that automatically for you. And again, also when you get a collection, you can get the count of the collection that leaves behind. With that, we can see that here in the logs, we have 13,000 messages in this inbox. The second thing I wanted to show here as we're talking about messages is the fact that we now rely on offset date time objects to materialize anything which is a date time, or date time offset instead of the calendar API. This new API from Java is more robust. It's more reliable. It's faster also, and it will allow you to do more advanced things in a more consistent manner. So here, for example, you can see that with a receipt date time, I added an hour for some reason, because maybe my business logic requires that I calculate last receive date time plus an hour. And then I was able to translate it to the local date time of my machine and output that to string, and you can see that in the logs here. Now, the next thing I want to show here are the batching.
Vincent,
yes?
Can you explain for us how can you know which parameters use in the select or order by, like subject or received date time?
Because, thank you for the question. So because this is a message collection page, you can basically, using the ... you can say, all right, give me the messages, build request, and .get, and you will see what kind of object you get back. Now, if you go back, if you navigate to that collection page, you can perfectly navigate then to here, thanks to our generic type, to the message object. So the message collection page is effectively a collection of messages. And here, when you navigate to the message, you can see all the different fields or properties that are available for you to use in filters, selects, order, and so on and so forth. So it's very easy for you to understand what's available and what can I use in my different requests, and to navigate between those. It's even more easy than it used to be with V2. Thank you for the question. Now, moving on to the batches, we have improved batch support. So JSON batches in Microsoft Graph are an ability for you as a developer to group multiple requests you want to send to Microsoft Graph in a single request, and to send all of that, well, as a batch to Microsoft Graph. So it saves a lot of round trips, it makes your app more performant, and it's generally a good practice to do those sort of things. So we've completely cleaned and revamped our batching API in the SDK, so it's much cleaner. So you can see that now I'm able to say, all right, I'm going to use the Graph client and the Fluent API like I did just before here. But instead of executing the request right now, I'm going to build a batch and add it as a step for the batch. So my first step here is to get and the first request I'm adding to the batch is to get the current user, right? And the second step I'm adding here, like the previous thing I showed you earlier, is to get the 2 last messages. And again, while we do that, we also keep support for the OData Fluent API and all the nice things we already had previously. We just, instead of executing right now, we just put it in a batch to execute it later. Once we've built our batch with all the different requests we want to execute on Microsoft Graph, well, it's time to execute the batch itself. And again, this is much easier than it used to be. You can do graph client.batch.build request, post the batch, and pass the batch that you just built. So that will effectively get the batch with all its requests, send it to Microsoft Graph, and Microsoft Graph will process it, give you the response back. Once you get the response, well, you can get each individual step using the step ID you got when you added the step into the batch, and you can deserialize it automatically using our native deserializers and all the infrastructure we have natively. Again, this is much easier than it used to be previously, and get the user back. So here you'll see that if I move with my breakpoint, you'll see that here I got the username from the batch request from here automatically. And with that, those are all the new capabilities I wanted to show today to you with a new Java v3 SDK, and also it's also our SDK for Android. Again, all of that relies on the nice things we get from Azure Identity and MSAL from an authentication and authorization point of view, and it makes querying Microsoft Graph from a Java or an Android application much easier. You don't have to craft the request manually and so on and so forth. I will hand it back to Mesa to close this part.
Thank you, Vincent.
Thanks, Vincent, for guiding us through the demo. And as I said before, you can access the blog post through aka.ms/ga-java-v3 to have access to detailed information about the Java SDK v3 and find important links such as upgrade guide, where you can see all updates for this new version, include those mentioned here and others, and which improvements are considered as a breaking change and which are not. All of our libraries are open source and available on GitHub, including the Java SDK and others, where you can read our week, open issues, and submit pull requests. If you have any questions in how to build an app on top of Graph, you can post on Microsoft Q&A. As a final point, we recommend that you go to aka.ms/graph to have access to the Microsoft Graph documentation, getting started tutorials, latest news about Graph, and much more. Thank you so much for your attention, and I will hand back to Ipshita.
Thank you, Maisa, Vincent, and team. Thank you for sharing the Graph SDKs. We're super excited to try it out. Thank you so much, everyone. Thank you again. I think if you have any follow-up questions, you can just reach out, I think, to Vincent and Maisa, and also access the libraries that are publicly available on GitHub. Thank you so much.
Thank you. Have a good day.
Thanks.
Thank you. Bye-bye.
Thanks. Bye.